So in the last video we made all of these parts, and I see now that I missed a few fillets. I think I missed this fillet running around the outside. This is the downloaded file. Nothing is constrained, it's just a step file, and I broke this apart so we could make all of the pieces. So if you've got all of them modeled, let's put this together. So I'm going to start a new assembly, and then we'll just play around in the assembly environment a bit. Start by bringing in the base. Here we go. There's our base, and I'm going to place it grounded at origin. So right click, ground at origin. Your first part you always want to ground, and the first part should be something that's going to be fairly stable. So then let's go back and get the two levers and put them in position. So these will just be insert constraints. I'm going to do this all with constraints. Probably wouldn't be a bad design to do over and do with joints. All right, so they move independent of each other. So maybe a flush across the top. I think I'm going to leave that for now. And then we'll bring the links in. So we need two links and a plunger. And we'll just get this thing working. So I'll do an insert off of here to here. Oh, the bushing needs to go in there. So let's get that first. Yeah, we'll put that in first. That looks right. And then we'll put a link on there and a link over there. All right, and I like to every now and then jump out, kind of test it. Oh, that's constrained to that bushing, so we'll just constrain this the way it would be assembled for real. Like that bushing would hold the two together. The plunger, I'll do a mate, axis to axis, and that's going the wrong way. And then we'll constrain one more axis to axis. Okay, let's test it. Okay, so we'll get the last link. All right, we need our rivets yet. And I'm just now seeing that there's different sizes of rivets, and I didn't have us draw different sizes. So we might have to make a new rivet. Yeah, these are too big. So I'm going to measure this. We're going to fix this right now. So that is 0.1133. We want to take off 0.1133. I'm going to open this, change this extrusion minus 0.1133. right? So those rivets look okay, but now if I copy and paste this one is not going to be again because this is a different width and I don't have a second rivet. So I'm going to select this part and say save and replace right here. So that's going to save it as a new name and then do a replace component. This would be rivet 2. And let's see how much we need to take off of it. Point 3557. So we're going to subtract an additional 0.3557. Okay, so we've got our 3 rivets. And let's save this. And our new rivet. So what can we do with this thing? Right now it kind of just goes through itself, and in reality it would hit here somewhere, and then when it goes over center it would hit there. So to find out what that range of motion is, we can say this piece and this piece. I'll shift and select those 2 pieces and say they are part of a contact set. And when they hit, I don't want them to go through each other. And on the Inspect tab, I can turn on the contact solver. And now that will stop when that arm hits. So it's stopping as soon as the arm hits and stopping as soon as the arm hits here. Where is it actually hitting? It's hitting some, oh, you know what? It's hitting the fillet. So it's stopping as soon as it hits that fillet. So we've got our range of motion. We can measure this now. Measure from here to here. So we'll say 5 degrees, 4 degrees over 180. And if I bring this back around, when it goes over center there, we have 0.34 degrees. So just by turning on contact sets, you can very quickly find what our range of motion is. And if I turn that back off, now this will go through itself again. But I can add my final constraint. Like this is something that would go in a library, and you can't leave stuff just flexible like this because you may want it this way and the next user may want it like this. And then your models are going to change, and then you'll open your model and change it back. It's going to change the other user's model. You can also not have this part in another assembly, this assembly in another assembly in 2 different variations. So if on a table I want this closed and then opened, I'd have to save it as a new assembly if I didn't fully constrain this. So I'm going to add an angle constraint. And I'll pick this as my reference vector. And I can go down 0.34. Negative 0.34. There we go, negative 0.34. So now I'm just over center and it's locked in place. But then I can move this back. So let me write this down. Negative 0.34 is closed. And I can make this 184. And that's where it's hitting on the back side. So that would be fully open. So how do we make so that we can switch this between negative 0.34 and 184 without having to edit a constraint? We do that with positional representations. So I'll make a new positional rep, make a couple new ones, and this one will be called closed. We'll call this one half, and this one open, and we'll make one more and call it free. So with free, with the check mark on free, I'm in that positional rep. I'm going to do an override on the angle constraint and say it is suppressed. So as long as it's in free, this thing's free to rotate. If I go to open, I can override this. I can do it all from here as well. So I always want it to be, when I'm in open, I never want it suppressed. I don't want someone, if someone goes in the primary and suppresses it, and I'm using opened, I don't want it suppressed. So I'm going to check both of these. And this is going to be 184. And then half, oh, I was going to show when I'm overriding this, I don't have to switch. I can switch here. So I can go to half and say half is 90, apply that, and then I'll go to closed and check both of these. And this was negative 0.34 and apply that. And now I've added an override to closed, half, opened, and free. All right, so let's save this and see what we can do with these. Oh, you know what? I didn't add the handle or the rubber grip. The most difficult thing to place. Let's go place that. Grip. This one's difficult because it's a stretch fit. So first of all, we want it right in the center. And if I put this face on here, you can see it's not centered. And I'm digging into material here, and I'm flush down here. So actually it's at an angle because that end is flared out a little bit. So to do this right, I have to use planes. So I'm going to find the origin plane that runs down the center. This is why it's important to model around something that makes sense plane-wise. And go to my base and find a plane that's going to work there. So it's going to be XY, so I'll say constrain XY to XY and say OK. And now this should be perfectly centered, same amount of material squished around the metal piece on both sides. Let's see if we can do a constraint from face to face with a mate there. So where are we at here? And then I don't know that we can do, can we just go on that edge and that axis? Okay. So that's fully constrained. Let's make sure that we have our planes and stuff set right when we go to half. Yeah, I thought it didn't like the last mate that I added. Let me delete this one. And because it's a stretch fit and I said face to face, the center point of this circle is not quite in line with that axis. So to make sure that it's all the way on, I think I'm going to delete this mate. And I'm going to do a constraint center line to center line. So now it should be pushed right in against, but it can still pivot. And because it's a stretch fit, I think I'm going to have trouble with any face to face. So I think the best thing that I can do here is pick this face and just go with an edge and then just play with it until it looks right. So 0.01, 0.02, 5. That looks pretty good. If we go back to a shaded with edges, it's still kind of tearing in more here. Again, this is a piece of rubber, so it would stretch around this. Could probably take that a little bit more, 0.03. Now it's a little bit in up here and a little bit more down there, but that should be fully constrained. So there's closed, there's half, and my piece flipped around. So, and the reason it was able to flip around is because I went from this 0 position up to the 90 position, and I said this face is aligned with this edge, and this fulfills that. So that actually is true. So we got to come up with a better way. So I'm going to go back to primary, and we're going to delete this 0.03. Try something different. So let's try an angle. So this edge and the barrel there, so I have an axis running down the center, and I'm going to go to an angle, and my explicit reference, I can tell you what, I'm going to pick this edge. So why is this line not, there we go. Now the arrows are pointing the same way, so 0 would be straight down. My explicit reference vector, I'll just pick the side of this face. So my lines are both pointing in the same direction with 0 degrees, and then instead of doing that 0.03, I'll try 0.5, negative 0.5 degrees. Actually, that's really close to what I had, but I used an angle instead of a mate. And then we'll come back and flex this and see if that keeps our rubber grip in place. All right, and then if I go to free, I can still drag this. All right, I think we're fully constrained. We have our positional reps set up. So let's put this on a tabletop, and then you can see what this looks like in another assembly and how you can use positional reps. So let's start a new assembly. We'll bring in some piece of furniture. This is on my drive already, so I don't have to go get something out of Vault. And we want to put some clamps on here. All right, so I can copy it here, then I don't have to browse out and get it. And then I want some more, and I'm going to put them all flush with each other because they're going to all go on top. And then we'll put one in each corner. So flush and mate. Oh, that's angled, so I'm going to have to go off the edge. So that one is constrained. So you're going to go over here, and we'll go with the mate. That one's constrained. And we have one more. Okay, so if I was to go back to this assembly and change this angle to 45, this assembly gets all of their clamps at 45. So this makes a horrible library part without negative 0.34. This makes a horrible library part without positional reps, because with positional reps, I can find it in the browser, go to representations, positions, and say you should be half. And now I have the same assembly in varying positions. So I'll make this one, I'll find it in the browser, and I'll say you are positional reps are open. Oh, well, I had my contacts all set up in order to know how far I could go, and I didn't take into account this tabletop, so we need to do some changes here. Push that over a couple inches, and we can see how much freedom we actually have by going to positions, free, and you'd think it would move because we put it in free, and the assembly is free, but an under-constrained assembly when brought in as a subassembly is always kind of grouped or rigid. But since we know there's some degrees of freedom that we want to be able to flex, we can say make this assembly flexible, this subassembly. Now that the subassembly is flexible, we can freely flex this. And if I turn on my contact sets, it'll still honor those contact sets. And I can say this piece is a contact set as well. Select my cabinet and say you're also a contact set. And now it stops, and I can see my range of motion. So positional reps are fantastic for having multiple instances of the same subassembly inside of an assembly. You can have them in varying positions, so hinges, cylinders, anything that's going to slide or pivot, and you don't want to have people going in and changing it where it may mess up someone else's assembly. If I go back and create a drawing view of this, positional reps, that's going to be too big. Positional reps can also be used in the drawing. So let's do something like this. So if I place an overlay over top of a view, I can say let's see half, and we'll do another overlay, and I want to see positional of open. And you can dimension this between the views, so you can capture what range of motion you would have. They kind of act as if they're one view, right? You can kind of make them behave as if they're one view. So I don't know, that's a dumb dimension, but you get where I'm going with this. So positional reps are fantastic in the drawing environment, because if you had positional reps on hinges and you use the hinges in some big assembly, in the drawing you could show the door swinging open and then draw in what that arc would be to show how much clearance you're going to need. You know, anything that's constrained to the hinge is going to swing when you manipulate that positional rep. Now in that case you would have to set the positional reps at the top level, right? Which I actually have some in this assembly. If I go to, oh, never mind, I do, okay, that's all right. So in this top level I'm going to create a new positional rep, and we'll just create a couple here. We went from assembling a clamp into positional reps pretty deep here. Didn't plan on going into this. But in this position, I can come in and switch where my clamp positions are. And my cabinet itself has some positions. I think, yep, drawer opened. So if I was to save this assembly, I could have, you know, this drawing view with the drawer opened and the clamps all closed, and then I could go to another position and then flex my hinges and my door knobs and cylinders and whatnot, and show different configurations in my top level assembly. So hopefully you got something out of that. This was a fun little video. I'll see you in the next one.